All right. Welcome to the very first webinar of the ASB Young Professionals. If you are not currently a member of the American Society of Baking, I have to ask, what are you waiting for? You can join at no cost for your first year, and as a young professional, ages 40 and under, you'll enjoy the reduced rate of $99 each year after. The benefits of membership are priceless when you're trying to jumpstart your career. Check out the American Society of Baking website at asbe.org to join today. Today, our webinar titled Introduction to Bakery Processes from Concept Through Construction will be presented by Charles Albertone. Charles is a project manager and industrial engineer with the Austin Company. He has a bachelor's in industrial engineering and an executive MBA. In addition to this, he is also a certified project manager. Charles is associated with AIB, IBIE, and OSHA, to name a few. He is also a member of the Young Professionals Committee of ASB. On a personal note, Charles is, above all, a proud new father of a beautiful baby boy. The Austin Company is a member of ABA, AIB, BNCMA, BEMA, and ASB. The company was founded in 1878, and they have become well known for their patented design and build process known as the Austin method. We will have time at the end of this presentation for any questions you may have. You can submit your questions directly through the webinar screen. So with that, Charles, the stage is yours.
Thanks, Brittany. I first want to caution everybody that I am not a baker, not even in my own household. I've been with Austin for almost 7 years and have focused on the baking industry, but if you need help with a recipe, I am not the person to ask. The Austin Company, a few other things about it real quick. We do some site selection and incentive negotiation if you are planning on building a new facility. We will master plan that, starting with a blank sheet of paper, developing an ideal layout. Then you try to find a site or existing building as close as possible without making too many concessions. And then the Austin method that Brittany alluded to, essentially what it is it's an integrated design build approach. Again, it's a registered trademark process that we have, and it allows us to basically establish the guaranteed maximum price of a project after you've only expended up to maybe 10% of the engineering. And then we get started with engineering of items that are more critical in the field, such as footers and foundations, and we begin constructing those while we're still ironing out the final details of an office layout, for example. So it's just a way to get into the field quicker and get completed quicker so that you could start making more money. This is a two-part agenda for today. One going to be focusing on the bakery processes introduction, as the title indicates, and then also going to talk about construction items. Some of the goal key takeaways will be to understand the basic processes involved in making a bakery product, gaining knowledge on the different types of systems that can create a unique product, and introducing the fundamental ingredients and optional additives for recipes. On the construction side, we'd really like you to gain an appreciation of the design and construction process of a standard bakery, that the site is more than just acquiring a piece of land, and designing the building is more than just creating a shell to house the process equipment. And then the actual field process itself is more than just executing the plans. It's ensuring that the sanitary details are being followed in accordance with scope, schedule, and cost for our clients. Throughout the presentation, I hope to be illustrating typical construction details to consider where applicable. Austin encourages starting any meeting with more than 3 people with a safety short. So I will be providing one for bakeries and one for construction. Starting with safeties and bakeries, I'm not going to read this whole thing, but specifically the wet floors around mixing, especially after a sanitation process. Posting notice signs is helpful, but cleanup is the most crucial. And then in the packaging area or panhandling, we often see manual handling of heavy trays for long durations. We either need to account for this with equipment or robots that will lift this product for us, or having a floater position to give frequent breaks if the manual handling is absolutely required. Bottom line is, if you train your people, safety in bakeries can be managed. On the construction site, this is a typical sign that we would actually have in our construction trailers. PPE obviously stands for personal protective equipment. You see the hard hat, safety glasses, no short sleeve, no tank tops. I mean, safety vest, long pants, and work boots. On the right, you also see multiple languages if it's appropriate. And then additional items might be required for specific tasks, such as welding. You might need to wear gloves, or if you're jackhammering, for example, you might need ear protection or gloves. So again, these are minimum required to enter the site, but then additional requirements may be needed. Our goal is always 0 accidents. We like people to go home the way they arrived. So I think that's a pretty good goal that we can all share. And then lastly, I also wanted to touch on good manufacturing practices, or GMPs. It's not necessarily personal safety, but it's food safety, and it avoids wasted product or worse, bad publicity that may come with a recall. So some of the things that they do in bakeries are hair nets, including beard nets if you have a beard. No loose jewelry or rings with any stone settings in there. All items are usually required to be in your pockets below the waist, and some bakeries even make you wear smocks or over jackets. Typically, these don't apply in a construction site because you're not making product while it's under construction. However, in a renovation project where you might have a 2 or 3 line operation and some construction might be going on one of the lines, the construction areas must be properly barricaded to avoid product contamination. Lastly, I should note that, for the ladies out there, the nail polish or fake nails, if you're working on the line, are also usually discouraged, or they'll make you wear gloves. So just a couple notes there with GMP, and then we can get started into the rest of the presentation. I'm going to start by introducing bread processing steps that I'll be covering throughout this presentation. Just going through the list, starting at the top left, you have your mixing, and then fermentation and or floor time. Followed by makeup, which consists of various processes such as dividing, rounding, proofing, sheeting, molding, and panning. From there, it goes into a proofer typically, into an oven, then cools, then it gets sliced for packaging, and then it gets off to shipment or into a warehouse or a freezer. When I say the term makeup throughout this presentation, that's what I'm familiar with. Some bakeries call it machining, laminating. Again, different verbiage for different bakeries or processes. Lastly, other items that can be included, usually within that packaging bullet, is scoring or cutting of the product, metal detection, twist tie closures. However, all of that is usually within the packaging footprint. Introducing bread dough systems. I apologize if this graphics are slightly hard to read. It basically takes you through sponge and dough, straight dough, liquid sponge, continuous mix, no-time dough, and the Chorleywood process. And really, the only thing I really wanted to illustrate here is there's a lot of different types of systems that you can use, and the main difference is the number of mixes and if there's a fermentation process. The numbers all the way to the left are a time frame from scaling all the way to packaging. So sponge and dough could take up to 7 hours from start to finish, where a no-time dough might only take 3.5 hours. The main difference between a liquid sponge and a sponge and dough, that's a common question that people often have. It's that the sponge and dough has over 40% of the dough already mixed into it, so it requires a longer fermentation time, where the liquid sponge usually consists of, well, it's much less than 40% of the dough. The next graphic just kind of talks the pros and cons of each process. Again, I'm not going to read this through. I'm just going to highlight a few of them. A sponge and dough, one of the bigger positives of this process is it has a second mix process. So it allows you to correct mistakes, perhaps, in batching or in the first mix. And then after that first fermentation, if you've noticed that something's just not right, you can correct that in the second mix. A pro of the liquid sponge process is that it's one sponge for many doughs. So you have a uniformity of product. You could kind of make rolls and bread as long as the ingredients are relatively the same. You don't have very much ingredients into that liquid sponge already. A con, for example, as for the continuous mix would be just lack of flavor, shelf life, and crumb strength. Continuous mix processes, basically it's made to be mixed and then basically shipped out. So it doesn't, and it's quick, so it's not meant to be the most tasteful product if you want to be frank about it. So to dive into these processes a little bit more, fermentation or floor time, it usually what it's doing is it's allowing the dough to rest to become more elastic. The picture up on the right shows what they call a dough window. Bakers use this type of a test, a manual test, to see if the dough is ready to be put into the makeup lines. And then I just also wanted to note that retarding is a form of fermentation, but what it really does is it elongates fermentation through refrigeration. The pros is that the flavor development can continue, and you can make larger batches because you'll just be able to throw it in the fridge for a day and wait till you needed to run that batch again. The problem, as with any refrigeration process, is it does dry out the dough. So that needs to be taken into consideration when you're formulating your recipe. To differentiate fermentation and proofing, they can appear to be very similar processes. The picture at the top left is a fermentation room, which occurs after mixing usually. Those are dough troghs that are shown. It develops the flavor. The room is typically at about 80 degrees Fahrenheit and 80% relative humidity. Whereas the proofer occurs after makeup, and its function is to rise the dough, and that is usually at about 100-degree temperature because of the heat gained from the fermentation process. That dough actually warms up throughout that process. And its humidity is at 95% relative humidity. A couple design or construction considerations when designing these two types of rooms are floor space for sure, and the room design, temperature and humidity control systems, floor drains, wall construction for ease of washdown, for example, as you see in the picture on the bottom right. Insulated metal panels, or we call them IMP panels, are used. They're very sanitary, clean, and easy to wash down. Lighting, you don't want any glass in any of the bulbs for food safety concerns. And then motion detection, even for energy efficiency. Most of these rooms are not areas where workers operate very often. So keeping the lights off most of the time is just a good practice. I want to talk a couple through the mixing stages of what the dough goes through as it's going through, as it's in the mixer. The first stage of the mix is what's called pickup. The dough is sticky, cold, and lumpy. And as you continue to mix it, it starts going through what they call initial development. It's getting warmer, smoother, a little drier. Then the cleanup, the dough is at its maximum stiffness. You'll actually even hear it slapping around the mixer, and it comes together as one mass. It's no longer a bunch of separate ingredients. The ideal stage is this final development, where the dough is at the correct temperature and handling quality. If you continue to mix, it's called letdown. With about 1 to 3 minutes of overmix, the dough starts becoming too warm and sticky. However, it can be recovered with floor time. And then after 3 minutes, the dough begins to liquefy, and you've essentially lost that batch. So you definitely want to avoid overmix is the purpose of this slide. Some typical mixers and ovens, just to illustrate them. Most commercial bakeries I've been in have the horizontal mixer, the top left picture, but also the vertical mixer is a very popular one as well. And same thing with the oven. Two of the most common ovens are the tunnel oven shown on the left and the rack oven on the right. Tunnel ovens are great for straight-through processes if you have a long building. Otherwise, a lot of bakers will go to the rack oven configuration. Some design considerations for mixers and ovens, mixer foundations and pedestals, scale pits, overhead ingredient lines feeding the mixers. All of those are very critical components to have an efficient mixing operation. And then for the oven, you definitely want an isolation pad. You want the oven to be sitting on its own foundation so that the floor essentially does not crack due to temperature variations. You want to run all the electric underground, and the gas and steam utilities, they want to be located at the proper positions. The other thing I wanted to mention about the oven is that it's often called a kill stage for all sanitation considerations. So your clean and dirty trows or maintenance tools, you kind of have to consider all of this in your design and plan for it. Are you going to have a trow washing return to go from finished goods back to the raw materials, and you're going to have to sanitize that trow, or are you just going to have one trow set for all of the raw product and another trow set for all of the finished good product? So again, things to consider as you're figuring out how you want to lay out your bakery. Quick slide here to just talk about the general relationship in baking times and temperatures. If you have a small roll, for example, it can go through an oven pretty quickly, but it's going to be a very high temperature oven. It might go through that tunnel oven, maybe 3 to 8 minutes, and it'll be done. Whereas like a loaf of bread might need to go through that tunnel oven for 25 minutes, but the temperature is going to be reduced compared to that roll. It allows it to obviously cook through the inside more consistently. To illustrate a couple cooling and packaging equipments, the most common cooler I've seen through the commercial bakeries are the spiral coolers, top left. But if space or quickly cooling a product is a concern, you could see a blast cooler. Some design considerations for cooling is, do you enclose that spiral cooler and condition the air, or is it just an ambient process where the spiral essentially is just acting as a long conveyor and allowing the product to come down to temperature through just your standard air, plant air. Packaging, the thing that you really have to plan for the most in packaging, it sounds simple, but you'd be surprised at how often packaging equipment moves and how automation adds to not only the footprint but the needs of compressed air. Compressed air is very critical in the packaging process. And as is floor space, not only for the automation perhaps that you might want to do in the future, but for building pallets and cross-docking if your bakery does those type of functions. Talk about ingredients for a few minutes. There's in every bread there's 4 required ingredients. That's a flour, salt, water, and yeast. Flour providing the structure, salt the flavor, water for hydration, and yeast for the air. The optional ingredients, again, I'm not going to read through them all, but they typically just provide food for the required ingredients, and the additives are typically there to just condition the dough. You want it softened or weakened or stronger, or however whatever you want your product to end up as, you might be looking at some additives. Talk a little about bread labels. I don't know how many on the line are actual bakers, but if you've seen a commercial bakery recipe, everything's what's in what they call baker's percent. So instead of a typical recipe like at your household, you might have 1 cup of flour, half a cup of water, 1 tablespoon of yeast, or 1 teaspoon of salt, and it'll say it serves 4, and then you scale it as necessary. A baker's percent bases everything on flour being 100%, and they have to give you a given weight. So they'll say flour is 100%, and there's 10 pounds of flour. And then from there, you can calculate the rest of it based on the baker's percent of that recipe. So in this example, if water was 60% of baker's percent, you know that that's 6 pounds of water. And then it yields 16.5, this example yields 16.5 pounds of dough. And essentially it's similar to in comparison to metric versus imperial measurements that we use in the United States. So It's just a way that some people think is easier, and it's just different, and I just wanted to point that out. The other thing I wanted to illustrate on bread labels is what they call the 2% line. On a label, everything is listed in order of the most percentage of the ingredient to the least percentage of the ingredient in that product. And yeast is typically about 2%. So anything below yeast on a label contains less than 2% of the formula. So if you're concerned about certain chemicals or certain products that you're putting in your body, but you know you could tolerate perhaps a slight amount of it, just look and make sure it's below the yeast in the ingredients, and it should be less than 2%. When talking about bread quality, bakers are typically concerned about the time and temperatures of each process, along with the cost, not only the ingredient and labor costs, but utility costs. So if you need to run an oven at high temperature for long times, for example, that obviously costs that baker a significant amount of money. Whereas the consumer, sure, he cares about that the baker stays in business, of course, to be able to keep providing bread, but ultimately the consumer is concerned about taste and price. There's some other things listed in here like lack of foreign material that I think we can all say, goes without saying. But ultimately, price and taste are what the consumer bases everything off of. A little trend in baking that I thought was pretty interesting. The reuse of mixed dough into a recipe. Typically, I'll use an example of a pita line, for example. If you're creating a round product, your laminating line will actually produce a square product, and then you cut it to match the shape that you need. And then what usually will occur is that waste goes to a side conveyor and goes back into the mix. It improves the volume, it minimizes waste, and it improves the consistency between the batches. However, it's starting to not be considered such a great practice for the purpose of traceability and allergens. What if there was a defect or a recall? Where would you know how to start and stop those doughs, especially if you're a 24/7 operation? There could be small amounts of dough made from the morning mix that are still showing their signs in the afternoon mix. So it's really hard from a baker's standpoint to really get that under control if this process is something you're still willing to do. All right, I wanted to talk a little bit about what we call the standard bakery. It is this example I'm going to show you is about 125,000 square feet, a little less than that. Some things to notice are the straight line flow of everything. It moves from left to right on the paper. I've circled two areas there. Again, I apologize for the graphic, but I'll explain what those are. They are isolated truckers' toilet and rest areas for shipping and receiving. A lot of times the truck drivers are not your employees, so these are contained areas that the trucker cannot get into the bakery building, essentially. So it's a safety aspect, but you're also providing an amenity for the drivers. The other main item on our standard bakery is what we call the service or sanitation corridor. And this is basically a corridor that separates the bake shop from any non-clean areas. What we will do, it's not shown on this graphic, I apologize, but I have a picture later on in the presentation showing a sanitation room. And what a sanitation room, it'll be adjacent to the corridor, and you have no choice of going through this sanitation room to get into the bakery, and you would have to wash your hands, wash your feet if a boot wash is necessary. You have to do all the proper things in this sanitation room prior to gaining access into the process area. Some other things that we consider while we're designing is that corridor or in between any of the, this is a bun and a bread line. The bun line is on the top, the bread line is on the bottom. In between those, you can have what we call a piping aisle. Again, I'll elaborate a little bit on that later on in the presentation. But if you've looked up in some bakeries, it kind of looks like somebody just threw spaghetti up there, didn't really plan for any of the process utilities. the water, the gas, the flour, anything where we try to make sure that we have areas of overhead that are designated for pipe runs that are easily cleaned with a lift truck, and also looks tidy if that is desired. Air pressurization always moves from the bake shop to less clean air, so everything will basically be moving from the bake shop outside into the corridor, outside the doors, into the office areas. All of that process occurs so that the airflow in the bake shop is not contaminated with any dirty process. We also, as of the past few years, I'm sure you guys are seeing it as well, having to deal with utility consumption reduction or reuse to get LEED certified or accredited buildings. So again, those are just some of the basic things we would consider when laying out a standard bakery. And then just to wrap up this slide, I wanted to revisit the bakery processes with you so I could show them to you graphically within a bakery if you're not already familiar with them. So receiving obviously occurs all the way to the left. You receive it via truck and you put it away in pallets, pallet racks, or liquid tanks, bulk tanks. The scaling occurs. These are pre-mixes that will be introduced into the mixing operation. The mixing is then identified graphically here. The makeup or laminating process is next, followed by proofing. These proofers are enclosed IMP rooms, as shown on the previous slide. The ovens or baking are shown here. One's a tunnel oven, one's a chain oven, if you want to call it that. Cooling, these are both spiral coolers. Neither of them are enclosed in a room, though, so these are just ambient coolers. And then you have packaging for wrapping the product, and then ultimately shipping. To move on to the standard bakery site, this is a 16-acre site which would accommodate the floor plan we just reviewed. Some design considerations for safety and security. We have separate truck and car entrances, as well as separated truck entrances for shipping and receiving, each with their own guardhouse. So again, you never want car and truck traffic crossing each other, so that's a safety thing. And then a food safety issue is making sure that there's a guardhouse to validate that receiving trucks are coming in and bringing the right product, and as well as shipping, leaving the site is occurring properly. We also, whenever possible, always try to make sure the truckers are backing in over their left shoulder. It's a little tedious fact, but it's a lot safer for a tractor trailer operator to back in over his left shoulder. And then also there's a perimeter fence shown on the site as well. That's also another food safety item that a lot of bakers are starting to implement. Regarding sanitation, as you can see in the lower part of the screen, there's 2 detention basins. A lot of city codes are now requiring stormwater control and runoff, so these are inevitable, but you want to keep them as far away as the bake shop as possible to not attract the pests. Same with trees. In the front of the parking lot, you might want some trees to make your building look aesthetically pleasing to the public, which is fine, but again, you want to try to keep and minimize those away from the bake shop as much as possible. Other considerations would be some future expansion. Are you looking at potentially expanding this plant, or once you maximize this one, are you thinking of another facility? So that's something to be considered. And a fire loop. This site actually shows a complete fire loop, and what this does is the fire marshal will typically, by code, require this to be called an unlimited area building. If you don't have this complete fire loop, not all sites are able to do this. It just would require more expensive construction with firewalls and things like that within your facility. That basically what it does is it allows a fire, if God forbid, if something happened in your plant, a fire would be able to be controlled within a certain portion of the building. If if you have a fire loop, essentially your whole building is exposed, but at the same time it's also easily accessible to a fire truck. Last other considerations would be the rail line shown here. If your site is located near a rail facility for bulk ingredient receiving, because it's typically cheaper, you want to locate those as closely to the bulk tanks in the receiving area as possible. And then I also wanted to show that this actually site was constructed very similar to that standard bakery site. So you could see an aerial of the things I was just talking about. All right, wanted to talk a little bit about schedule. This is going to be a 9-month arbitrary schedule starting in February of earlier this year. And I'm going to start with a Revit image. Revit is something I'll also talk about in another slide or two, but it's a CAD tool, a 3D modeling tool that we are using not only to create images such as this, but to also interference check. So like I said, I'll elaborate a little bit on that on the next slide, but to quickly go through this, you'll see that the first thing that we did would be footers and foundations for this project. And then again, I'm gonna show you a picture of it actually during construction. So this is a photo of that site during construction. The next thing you would do is tilt up the load-bearing precast, and a picture of that as well. Next would be the installation of structural steel, columns and tubes. And again, a picture. And then lastly, you'll see the finished roof with all the rooftop equipment. That occurs, like I said, about 9 months after the schedule. And there's a picture of that. Notice that the roof is a white, what we call TPO. It's an insulated roof, which it reduces the bake shop temperature 10 degrees, which qualifies for energy efficiency for green or LEED, whatever certification you're trying to obtain. The only thing with white, and again you'll see it on the next slide, a lot of bakeries like to have everything white. It requires a little bit more maintenance or cleaning in this case, but in a bakery that's not necessarily a bad thing, recognizing areas that need to be cleaned before they become problematic. So to talk a little bit about the interior, the structural steel and roof design, this is a Revit rendering again. Tube columns and joists, so there's no crevices. An IMP ceiling and roof, so it's flat, smooth, it's cleanable, and those are actually anchored directly into the tube, so there's no screws or fasteners exposed, nothing to cut your hand on, nothing to build a harbridge point for either. So again, as I mentioned, Revit is great for interference checking between disciplines. Again, I'm not going to talk about Austin during this presentation, but a lot of companies don't have everything in one house. Austin does, but perhaps you're using a structural engineer and then you're subbing out the mechanical engineering design to somebody else. Well, they might just give you both files that say, okay, here's the structural design and then here's the mechanical design. Well, what Revit will do is interference check, and you might have a steel column going through HVAC duct, for example. So Revit is very good to identify those things prior to them becoming issues in the field. And then I'm also going to, my next click here is going to show you this, a similar view of an actual construction site, and you'll see how much brighter it is when it's all white. But this is actual construction. All right, a couple sanitation detail considerations to conclude with. The pipe hanger, what we do is we say no threaded rods. Again, that's not good within a bakery. And then this would be an example of the pipe aisle I was talking about earlier on. You know, you want a coordinated area, not only to design your structural steel around, but just to make it a cleaner appearance. Also, this is the sanitation room I referenced earlier as well. This would be a room you would have to pass through prior to getting into the bake shop from any dirty area. And again, some of these rooms might have requirements that won't let you through unless they know that the faucet has been on. This particular situation does not have that, but hopefully after you passed five faucets, you've washed your hands and dried them thoroughly prior to entering the bake shop. Vertical storing dock levelers, they're safer than your typical dock levelers that are in some of the older facilities. They don't require manual operation, somebody bending over and lifting up a heavy plate. They also store upright so that a forklift can't drive through an open door if that's actually the situation. And then the other thing that I'm not sure the picture does a great job showing, but with your regular dock pits, you have a lot of crevices and harborage issues. Here is one long pit, recessed pit that is easily cleaned, doesn't have any areas for pests to hide or reside or anything like that. So again, this is something we strongly consider. And then I apologize, I didn't have a very good picture, but the other thing that is critical within a bakery is standing off of pipes or electrical panels. The standoff will provide space to effectively clean. You want to use underground conduit as much as possible. If for whatever reason space is an issue and you need that enclosure to be up against a wall, that's okay. It just requires a seal, a caulk around it, and it's pretty difficult to obtain a tight seal on a completely flat wall for a long duration. It's kind of a maintenance item that the bake shop always has to, that the bakery always has to be aware of. So with that, I do want to thank you for your time and joining this seminar. Brittany has a couple items for ASB that she wants to walk through prior to doing the question and answer session, but I highly encourage you guys to stay on and ask questions if you need be. Brittany?
Yes, thank you, Charles. So while we have you, just want to let you know that our next webinar will be taking place in early 2014, around February. It'll be a Young Professional's Guide to Baking Tech. So if you've never attended Baking Tech, or maybe you've only been there once or twice and are looking to take more advantage of the conference, I highly recommend that you participate in this webinar because it'll have all the good recommendations for different activities and events that you can participate in. Baking Tech is actually going to take place in Chicago once again, March 2nd through the 4th. So save that on your calendar. Also, just a heads up, if you are attending Baking Tech, the Young Professionals Committee will have a social event once again on Sunday night. Last year we went to Lucky Strike in Chicago and we had a great time. This year we've got some exciting events planned. We'll just mention a scavenger hunt. So if you are excited about that, we hope that you'll make it out. So with that, just want to turn back to one of the questions that was submitted by one of our attendees, Alan. Alan asked, will the webinar notes be available via email?
Yeah, I could post this the webinar on you know, whether we post it to the ASB site or we send out a blast email. The answer is yes.
Yeah, I believe we are going to have the recording posted on the ASB website, so you can check out there. And there actually is an archive of previous webinars if anyone is interested as well. We have an attendee, Mike Orr, has raised his hand, and we can unmute him and he can ask his question. Mike? All right, I guess there's no question there. All right, anybody else have a last-minute question they'd like to submit? Charles, I think you did good.
Thanks, Brittany. You did well.
Thank you. All right, everyone.
You
Take care. All right, farewell.